Hi, we are Group 6, and in this project, we would like to identify whether a given user is a bot or a real account. We would like to identify those accounts based on the characteristics such as number of tweets, percentage of political tweets, number of followers, and other derived attributes.
So as far as the importance is concerned for this project, we need only look at the kind of 2016 US presidential election, where a series of Russian troll accounts spread disinformation and false political views and kind of ended up influencing the way that people voted in the election. This isn't a problem isolated only to the United States, but to countries all around the world. And having a way to classify these accounts accurately and reliably is something that's quite important.
In this table containing the variable we are using in our training data sets, after using the requested feature elimination, we found that the 5 most important ones were maximum tweet number of tweets, number of followings, number of followers, and the length of the screen name.
In this project, we have 3 hypotheses that we like to test on. The first one is we hypothesize that bot account posts significant different numbers of tweets than the human account, and also they have different percentage of political content than the human users. The third, we have hypothesized that k-nearest neighbor will be able to gain higher accuracy compared to decision tree machine learning algorithm. The result I found, as shown on the slide, we successfully rejected the null hypothesis for the number of tweets posted and percent political, that there are statistically significant difference between bot and human user for these 2 attributes in which the p-values are all significantly smaller than 5%. Also, the decision tree does show performed a lot better in our testing dataset compared to the k-nearest neighbor, in which the decision tree is able to achieve 95.7% of accuracy compared to the 90.4 on k-nearest neighbor.
So for our classification results, we ended up testing 4 algorithms: k-nearest neighbors, Gaussian and multinomial naive Bayes, and finally decision trees. From our initial run, we found that decision trees were the most accurate on our test data, but we were definitely overfitting since we had 100% train accuracy. After hyperparameter tuning using grid search CV for our decision tree classifier, we ended up with the following values for our test accuracy and our train accuracy, being 96.12% and 97.8% respectively. For our classification metrics, we used a confusion matrix in order to show the false positives and the false negatives of our classifier, as well as an ROC curve, showing how well our classifier differentiates class 0 and class 1 types of objects. In this case, bot accounts and real user accounts.
Now, I'll move on to the visualization for our selected features. For the first graph, we're showing the uniformities of tweet hours between the bot and human. As clearly shown on the graph, bot posts tweets in a much wider time range compared to the human. Next, we have comparison between length of screen name between the bot and human. Again, bot oftentimes have much longer screen name, which we hypothesize that this may be generated automatically.
We would also like to see the relationship between bots and real accounts by using the number of followers and followings. Based on the visualization, it looks like both real and bot accounts have a positive linear correlation between the number of followings and followers. We also wanted to see the correlation between the number of tweets and the percentage of political tweets between the bots and the users. And by looking at the graph, it looks like bots have a higher percentage of political tweets.
So now comes our final discussion and ideas for future work. So through our project, we found that decision trees were the most effective model in terms of F1 score, accuracy, precision, and recall. Derived attributes were also helpful in terms of finding the maximum number of tweets in a day in order to account for bot activity, which would kind of spike, as well as percentage political, which would help us identify overly political accounts, in this case, mostly bot accounts. In the future, we'd like to create a separate classifier, which is just responsible for identifying whether a tweet is political, as well as increasing the size of our training data set and generating more derived attributes. It'd also be interesting to integrate this with Tweepy in order to classify tweets for an account in real time.
Thank you.